So this is our last maths lesson of the week, which is focused primarily on fractions. And today is going to be about comparing fractions. Now, comparing fractions is a fairly easy job, as long as we have a common denominator. Because what we can't do is compare two fractions where the denominators are different without doing anything. Because, yes, we may have a rough idea how big one fraction is compared to another, but we can never be 100% certain, which is where some of the tricks that we're going to look at today will come in. Now, if we look at our first example here, we've got 6 9s and we've got 4 9s. So beautifully, we have a common denominator. We have both out of 9. So therefore, we consider, well, which is bigger, 6 9s or 4 9s? And instantly, we would know that would be 6 9s because the 6 is bigger than the 4. So therefore, we can compare using the inequality symbol and show that 6 9s is greater than 4 9s. Now, our problems start to arise when we look at the next example, because we have 2/3 compared to 5 9s. And we've obviously got to work out which is our bigger fraction, and we can't currently, because I can't necessarily compare ninths and thirds, and I know you can't. So there are two approaches you can take. Now, one, I'm not going to be able to show you effectively on here, but it is where you would use some sort of fraction rule when you have your ninths compared to your thirds, where you have a whole bar of the same length. And the reason I can't show you is because you've seen with my drawings in here, I won't get these fractions as equal parts. But I'm going to show you the mathematical way, which I think is just as easy. Now, what we need to do is we need to look at 3 and we look at our 9. Okay, and I'm going to multiply one of these numbers to get it to the other. Now, instantly we know there's no point multiplying the 9. So we can multiply our 3. So we consider how many 3's go into 9. So we know we would do 3 times 3. So what that means is I can make this fraction into 9's, because I know 3 multiplied by 3 gives me that 9. So we're starting to find the equivalent. So because I've now multiplied that by 3, I do the same on the top, because whatever we do to the denominator, we do to the numerator. So 2 multiplied by 3 is 6. So what I can see now I've got is that 2/3 is actually equal to 6 9s. So therefore, 2/3 is greater than 5 9s, because 2/3 is 6 9s. Now, if you're confused on this part of how I've gone from thirds to 9s, how you can do it is, again, consider your common multiples. So I go 3, 6, 9, 12. I could go 9, 18. And of course, we can see from this that 9 is our common multiple. So therefore, we know we can make thirds into 9s. If at this point you're feeling a little bit confused, don't worry, we're going to look at a couple more examples. If you're feeling more confident, pause the video and have a go at comparing these two, and then come back and we'll have a look. Okay? For the rest of us who will still go, this is how it's going to work. We've got 3/4 and we've got 4/5. We've got two different denominators. So what we're going to do is we're going to list our multiples of 4 to begin with. So 4, 8, 12, 16, 20, 24, and 28. And I'm going to do exactly the same with my 5s. So 5, 10, 15, 20, 25, and I'm going to stop at 30. What I now need to identify is, do I have a common multiple between those two? And instantly I can see I have 20 here and I have 20 here, which means I'm going to make both of these fractions out of 20, because I can convert both to have that common denominator. So now we need to consider, what do I do to each? So if we look at 4, well, from 4 into 20, I multiply by 5. So whatever I do to my denominator, I do to my numerator. So 3 multiplied by 5 is 15. So I know 3/4 is equivalent to 15/20. If I go look on the other side, what do I do to 5 to get to 20? I multiply by 4. So the rule, whatever you do to the numerator and the denominator. Okay. So I multiply the numerator by 4, which gives me 16. So over here we can see I've got 3/4, which is 15/20, and here I've got 4/5, which is 16/20. We can now say which is bigger, 3/4 or 4/5. It's 4/5 because we know that is 16/20. And this is how this method needs to work. Again, what you may have noticed here, a quicker way to have done this might have been to have done 4 multiplied by 5 to get my common denominator of 20. Okay? So now we've got to compare 7/11 and 2/3. So let's do what we did as a first step here. Let's list our common multiples. So let's go with the multiples of 11 first. So 11, 22, 33, 44, 55. And then let's go with our multiples of 3. So 3, 6, 9, 12, 15, 18. Now if I stop there, we can see so far we haven't got a common multiple. Now if I kept going along this list, I would get there. But this is where the trick of doing 11 multiplied by 3 would come into it. Because we know 11 multiplied by 3 is 33. And just to prove that we could have done that, I go 18, 21, 24, 27, 30, and then 33. So we would have got there. But the quicker way could have been in that first instance, doing 11 multiplied by 3. But nevertheless, we have now got a common denominator of 33. So now we need to work out our numerators to be able to help us to compare. So 11 into 33, well obviously what we've done here is multiply by 3. So we do the same on the top, and 7 multiplied by 3 is 21. Now over here we've obviously gone 3's into 33. That is obviously multiplying by 11. So I'm going to do the same to my numerator. So 2 multiplied by 11 is 22. So now we can see I have 21 33rds or 22 33rds. I compare 7/11 to 2/3. Well, we can see that 2/3 would be bigger because 2/3 is 22 33rds compared to the 21 33rds. And that's how it works. Partly is identifying this, and then it's finding the common denominators from the common multiple. And then whatever you've done to the denominator, you do to the numerator. Some of you might find you need to watch it a few times, and of course, if you're still stuck, we will look at this at 10 o'clock. But if not, you have either A or B to do, and to compare them using that inequality symbol. Once you've done that, you've got your solve, you're explaining your thing. So your solve, always, sometimes, never true. If one denominator is a multiple of the other, you can simplify the fraction with the larger denominator to make the denominators the same. Well, that's confusing. But what it means is if you had something quarters and something 12s, it could be simplified to something quarters and something quarters. So instead of us making this quarters into 12s, we've made the 12s into quarters. So it's saying, is that doable? Can you actually simplify the larger fraction, or the, not necessarily large fraction with the larger denominator? Okay, so doing the opposite of what we've done. I'm leaving that very open-ended before now, because obviously that is something we will look at 10 o'clock. On your explain, we've got Ron makes 3/4 and 3/8 out of cubes. He thinks that 3/8 is equal to 3/4. Do you agree with him? So this is about you comparing. You're going to need that common denominator and then working out the numerator aspect to be able to prove whether he is right or wrong, and make sure you explain. And then on your think, you've got to order the fractions from greatest to smallest. You're given 3 sets. Obviously, you can see all the denominators are different. So on each set, you're going to need to work out the common denominator. Okay, obviously then working out the numerator and then go from there. Okay, obviously we'll look at a lot of this at 10 o'clock again. So if you have any questions, bring them along then. But up to that point, if you're all happy with this, give it a go, and you know where we are if not. Okay, we'll see you very soon, and best of luck with it.